Hi guys, welcome back to my channel. In today's presentation, we will discuss graphing of special functions, featuring quadratic functions. Before we continue, please watch my other tutorials and please subscribe to my channel. Thank you so much. So before we start graphing, let me introduce to you the standard form of equation for a quadratic function. We have here f of x is equal to a times the quantity x minus h squared plus k. In this function, the vertex is represented by hk. Also, given in the function, we have the value of a. This value of a is our multiplier to the pattern 1, 3, 5. This pattern represents the number of boxes we will be using to graph the quadratic function. To understand this better, we will have an example. In this example, we have f of x is equal to x squared. Step number 1, we need to plot the vertex hk. Our vertex is at 0, 0. Step number 2, since a is equal to 1, our pattern is 1, 3, 5 for the number of boxes. Step number 3, connect the vertex and the corners of the boxes. Don't forget to put the arrowheads at the end of your quadratic function. Okay, for our next example, we have f of x is equal to negative quantity x minus 1 squared plus 2. Step number 1, plot the vertex hk. Our vertex is 1, 2. Step number 2, since a is negative 1, our pattern will be negative 1, negative 3, negative 5 for the number of boxes. We will draw the boxes downward because a is negative. Step number 3, we connect the vertex to the corners of the boxes. Again, do not forget the arrowheads at the ends of your quadratic function. Okay, for our next example, we have f of x is equal to negative quantity x plus 3 squared plus 4. Step number 1, we plot the vertex hk. Here, our vertex is at negative 3, 4. Step number 2, since a is negative 1, our pattern will be negative 1, negative 3, negative 5, and we will draw the boxes downward because our a is negative. Each box that we draw corresponds to one unit of our Cartesian coordinate plane. And step number 3, we connect the vertex and the corners of our boxes. Do not forget to put the arrowheads at the ends of your quadratic function. The arrowhead means your line will extend to infinity. Okay, for our next example, we have f of x is equal to the quantity x minus 4 squared minus 5. Step number 1, we plot the vertex hk. Here, our vertex is 4, negative 5. Step number 2, since a is equal to 1, our pattern will be 1, 3, 5 for the number of boxes. Since a is positive, we need to draw the boxes upward. Each box that we draw corresponds to one unit. Step number 3, we connect the vertex and the corners of the boxes. Again, do not forget to put arrowheads at the ends of your quadratic function. These arrowheads will tell us that the function will continue and extend to infinity. Now we will discuss how to graph quadratic functions with a greater than 1 or a less than negative 1. Okay, for our first example, we have f of x is equal to 2 times the quantity x minus 4 squared minus 8. Step number 1, we plot the vertex hk. Here, our vertex is 4, negative 8. Step number 2, our a is equal to 2. Our pattern will be 2, 6, and 10. This will be the number of boxes that we will be drawing. Each box corresponds to one unit. Step number 3, we connect the vertex and the corners of those boxes. Do not forget to put the arrowheads of your quadratic function. Also, you will observe that this function has a vertical stretching. This means if your value of a is greater than 1, you will have a vertical stretch on your quadratic function. Okay, for our next example, we have f of x is equal to negative 3 times the quantity x minus 2 squared plus 10. Step number 1, we plot the vertex hk. Our vertex here is at 2, 10. Step number 2, since our A is negative 3, our pattern will be negative 3 and negative 9 for the number of boxes. Our pattern is negative, so our boxes will be drawn downwards. Also, notice that we only need 2 patterns because our function will not fit the graph if we will use negative 15. Anyway, we have arrowheads to tell us that this function will continue and extend to infinity. Step number 3, we connect the vertex and the corners of the boxes. This is another example of a function with vertical stretching. Okay, now we'll be discussing quadratic functions with values of a between 0 and 1. Okay, we have here an example. F of x is equal to 1 over 3 times x squared. Step number 1, we plot the vertex hk. Here, our vertex is at the origin, 0, 0. Step number 2, we have a is equal to 1 over 3. Our pattern will be 1 over 3, 3 over 3, and 5 over 3 for the number of boxes. Since our a is a fraction, we will be using scaling. 3 boxes corresponds to 1 unit. So for the first pattern, 1 over 3, we will have 1 box going up and 3 boxes going sideways. For the pattern 3 over 3, we will have 3 boxes going up and 3 boxes going sideways. For the pattern 5 over 3, we have 5 boxes going up and 3 boxes going sideways. Step number 3, we connect the vertex and the corners of the boxes. Again, we have to put arrowheads at the ends of our quadratic function. This will tell us that the quadratic function will extend up to infinity. You will also observe that this quadratic function has a vertical compression since the value of a is a fraction, 1 over 3. Okay, for our next example, we have f of x is equal to negative 1 over 2 times x squared plus 4. Step number 1, we plot the vertex hk. Our vertex here is at 0, 4. Step number 2, we have a is equal to negative 1 over 2. Our pattern will be negative 1 over 2, negative 3 over 2, and negative 5 over 2 for the number of boxes. Our scale here now will be 2 boxes corresponds to 1 unit. So from the vertex, we'll draw 1 box going down and then 2 boxes going sideways. From the corner of those boxes, we will draw 3 boxes going down and 2 boxes going sideways. And from the corners of those boxes, we will now draw 5 boxes going down and 2 boxes going sideways. Step number 3, we connect the vertex and the corners of the boxes using our quadratic function. Never forget that we have to put arrowheads at the end of our quadratic function. You can observe from this graph that there is a vertical compression because our a is a fraction, 1/2. And it opens downward because a is negative. And that's it for graphing quadratic function. Thanks for watching this video. Don't forget to hit the like and subscribe buttons below. Also, click the bell icon to get notified when I upload my next videos. Please share this video with your friends. Have a nice day!